So Unit 4 is all about looping, okay? And another name that's commonly used for it is repetition, okay? Now, since we are doing some kind of loop and we need to do our things so many times, whatever that time is, repeat 5 times, I need to do it 10 or whatever, we're still going to need some kind of Boolean condition to let us end the loop. Because if we don't end the loop, we're just stuck in what is called an infinite loop, okay? And we don't want to be stuck in an infinite loop because then our program will literally just hang, and this will happen to you. You'll mess up somehow, you'll run your program, and the computer will just like freeze up on you. Because somehow you made a mistake, you made some logical error, and you're now stuck in some kind of infinite loop. So if you ever do that and you need to exit out of your program, Control-C in Linux will get you out. Okay, so if your program locks up somehow, Control-C will get you out. So we need some kind of Boolean condition, and since we need a Boolean condition, we're going to be comparing some kind of value with something else. Keep looping while it's less than this. Keep looping while it's greater than something else, whatever it's going to be. We're using a Boolean condition, so it goes into a diamond. It's not if. We're going to see, we're going to start with a while to begin with, okay? So we're going to start with this structure called a while loop. And for a while loop, we're going to have a Boolean condition that while it is true, we do a chunk of code. Then it comes back and it checks the Boolean condition again. While it's true, we'll do the same stuff over and over again. Inside that Boolean expression, we need some kind of variable that is changing every time we go through our loop. Because we need that Boolean expression at some point to become false, so that we hop out of our loop. That variable we usually call a counter, or an iterator. Classic example is, I'm going to loop while I'm less than 10. And then we have a counter, and every time we go through the loop, we add 1 to it. When it reaches 10, our Boolean expression is false, and we hop out. Okay? So we're going to have some kind of counter, some kind of iterator, some kind of thing that's going to keep track of something. Okay? Usually it's counter. We could add to it, or sometimes we might want to subtract to it. Subtract from it. So we start at 10 and we count down. When we reach 0, then stop. Okay? Normally it's by 1. You could go up by 2s if there's some reason, like you're skip counting like you did in elementary school. Okay? So usually it's you're going up by 1 or down by 1, but whatever it is, 1s, 2s, 5s, you're going to have to count up or down. A lot of people and a lot of code you will see online will use a variable for this, and they'll just call it like I. I is the classic example. Okay? And literally they'll have a variable and its entire name is just I, small. We're not going to do that. That's a really bad idea. Okay? If you're keeping track of how many times you're going through the loop and you're counting up like number of sheep, then call it count of number of sheep, because that's what you're counting. Okay? Just calling something I gets really confusing when we get into larger programs and like there's I's all over the place. Okay? And you're like, what I am I counting from? So whatever it's called, call it whatever it's doing. Okay? That's just the easiest way. Okay, so many programming languages have this sort of generic form for a loop that looks something like this. Okay? So there's usually a keyword called while or some kind of variation of it. You usually have brackets and you put your Boolean expression in here. You indent and you do one or several commands. And then usually at the bottom you have some variable that you're using as your counter, and this variable will be present in your Boolean expression somehow. Okay? We have while, and then you'll have an end just so that you know what's going on, and the stuff inside is usually indented. Okay? So this is kind of the generic structure of what it would look like. So here's my very simple program, and literally all we're going to do is we're going to count up. So the person is going to give you some positive number, 10, 17, 25, whatever it happens to be, and you're going to count through the numbers starting at 0, because in computer science class we always start counting at 0. Okay? You went to elementary school, your teacher probably taught you to start counting at 1. That was actually incorrect. The first number is 0. And it's going to become super important later on that we get used to start counting at 0. Okay? So we're going to start counting at 0, and when we reach this number that the person gave us, we're going to stop. And we're literally just going to print out each number as we count through. Notice here I only showed this once. If I'm counting, because I don't know how many times we're going to show this. Is it like the person's going to put in 5 or 7 or 28? Like, I don't know. So you just show it once here. So the flow chart would look something like this. We're going to start. I'm going to create a variable called counter, and I'm going to assign it 0. Now, some programming languages you don't need to assign it 0. When you create a variable, it will just automatically be assigned the value 0. Go does this automatically. And if you literally try to create a variable and assign 0 to it, Go, when you lint it, will give you an error saying, hey, you don't need to do this, I'm doing it for you automatically. Python does it automatically for you. When you create a variable and it's of type integer, just throw 0 in and you're good to go. Some programming languages do not do this. C is the classic example. When you create an integer in C, it just has some random number sitting there. You run your program again, it has a different number in there, and you never know what number's in there. So some programming languages, you would want to assign the value 0 when you initiate it. Okay? So depending on your programming language, you might or might not want this in your flowchart. Okay? If you're just doing Python, you probably don't even want it. Go, you definitely wouldn't want it. C, you would definitely want it. Okay? Because you would want to assign 0 to your variable so it doesn't have some garbage floating around in it. We're going to get the value from the user, and then we're going to have our Boolean expression. So it's still a diamond, but we have while. Okay? So we're going to loop while counter is less than whatever the person gave us. Okay? So if they give us 5, counter currently is 0. Is 0 less than 5? Yes. Yes. So we go in and we do something. Okay? So I'm just going to show whatever the value is. Notice this looks like kind of like what you would see in Python. Okay? Doesn't have to be exactly like that. Remember, this is just a flowchart. And then we're going to have this line of code. I'm taking the variable counter, I'm adding 1 to it, and then I'm shoving it back into itself. Okay, that's what this means. I'm taking my whatever is there, currently it's 0, I'm adding 1 to it, so now it's 1, and I'm replacing 1 with what was currently there. This is only classically valid in programming class. This is a variable, we're adding 1 to it, and we're assigning it back to the variable. If you were in math class, just let me get my notepad here. If you were in math class and you had a variable, say x is assigned 5, and we did the exact same kind of equation, x is assigned x plus 1. Okay, so in math class, you wouldn't use counter, you would probably use x or y or something. Okay? But if I was to evaluate this now by placing what x is equal to, then I would say 5 is equal to 5 plus 1. 5 is equal to 6. 5 can't equal 6 in math class, right? But remember, in math class, this is an equal sign. In computer science class, it's not an equal sign. It's an assignment statement. Okay, so math teachers look at this and they get all freaked out and they're like, what the heck's going on? But they don't understand that this is not an equal sign. Okay, so now counter the first time through is going to be 1. Then notice where the arrow goes. it comes back to here. Okay, not like an if statement where it branches out, it loops back. 1 is less than 5, so we come down, we now print out 1, and then we have 1 plus 1, counter is now 2, and then we come back up. 2 is less than 5, so we print off 2, this now becomes 3, and then we come back. 3 is less than 5, print out 3, now we have 4, so we come back. 4 is less than 5, so we print out 4. Now this becomes 5, so we come back. Is 5 less than 5? No. So we hop out. So notice we printed out 0, 1, 2, 3, 4. We printed out 5 numbers, but we started at 0 and went to 4. That's different than like elementary school because you would have counted 1, 2, 3, 4, 5, right? So once again, we always start at 0. When we're done, notice we just hop to the very bottom. Okay, so this is sort of the classic representation of what a while loop would look like. In pseudocode, we get the positive integer. We do while counter is less than positive integer. We show it, we increment it. We have end while that matches our while. Everything in between we indent, and we're good to go. Now, in Python, there we go. Okay, so here's our classic program. Here's our function. I create a variable called counter and I'm assigning it 0. Technically you don't need that, but it's like nice to have. Okay, just so that people are aware of what's going on. I'm going to ask the user for a number and I'm going to convert it right to an integer here just to make my life easy because it matches what's going on in my diagram here. Okay, we'll talk about that in a minute. And then we enter while. So notice while is a reserved word. Notice we don't put it inside brackets because it's Python or Go. Okay, in C or some other languages you would put it in brackets. And then we have our print statement and then we increment our counter. Okay, so I'm going to put a breakpoint right here. And I'm just going to run my program. So just like the example we went over, I'm going to enter in 5, okay? So notice that positive integer is 5 and my counter is 0. I'm going to grab this whole Boolean expression and I'm going to add a watch so that we can see what the heck is going on, and notice it's true. Okay? So we loop while this is true. As soon as it becomes false, we're going to hop out. So we go through, we're going to print out our first number, which is 0. We add 1 to it, so now it's 1, and then we come back and this is checked again. It's still true, so we hop through. Okay, so we're going to print out 1, we add 1, we have 2, 2 is less than 5, so we go in again, we print out 2, we add 1 more, now we're at 3, 3 is still less than 5, we print out 3, we add 1, we got 4, 4 is less than 5, so we hop in again, we print out 4, we add 1, now we're at 5, and notice this turned to false. Okay, so now it's going to come from here and it's going to exit our loop and hop down to line 22. And notice that it actually did print out 0 through 4. Okay, 5 numbers, but 0 through 4.